Hello everyone, welcome back on our new space webinar. Today we are going to discuss one of the very important topic of space revolution. While government is helping startups for space innovation and launch projects, a great risk of the whole space industry is going to face due to the space debris increasing exponentially day by day. This will affect the sustainable orbital movement of satellite also. So our today's session is on space debris management. It is intended to give a clear picture of what you can do for space flight safety. So a quick introduction about our organization for those who are new to our channel. Our organization Team 2020 Helping Hands is a group for students, entrepreneurs and society. We aim to create a network of potential helpers to raise their helping hands towards those who need to be helped. Follow our LinkedIn page to know more. I am Moaz Hussain, founder and CEO of Team 2020, and it is an honor for us to introduce our valuable speaker, Professor Arunachalam, who is currently located in Virginia, USA. He had given 30 years of his life contributing in the growth of Indian space industry, that is R Rao Satellite Center, as a scientist. He is a great name in spreading knowledge on space topics to the students. Without taking longer in introducing him, I would like if he gives a brief note about his work before we start. And I'm glad to announce that soon we will be presenting online courses of IIT Bombay. Stay till the end. I will give you more details about it, and subscribe to this channel. Also follow our LinkedIn page to not miss that update. So now I request Mr. Professor to begin. So please, Professor, our audience is eager to have your words.
Thank you, Hussain. I will start the presentation. Good morning, everybody. Yeah, I'm Arunachalam, scientist retired from R Satellite Center, Bangalore. So I am going to give a talk on space debris and its management. So you all know it is the first satellite was launched by Russians in that is called Sputnik 1 on 4th October 1957 in elliptical orbit. And size of the satellite was like a football size. And that is the beginning of space era. That is the first man-made artificial satellite. With that, satellite technology started. But at the same time, the problem of space debris also started. But if you see Sputnik 1 stayed there for some 80 and odd days, and it is entered the atmosphere and totally burned. But if you see, there are so many debris have been developed, put by man-made efforts in the launching of satellites and other articles. It is going. This is going to make a big problem in our future space activities. So let us see what is the space debris. Space debris encompasses both natural and artificial. Meteors are on orbit around the sun, while most artificial debris are around the Earth. So artificial and later is more commonly referred as orbital debris, which we are of concern to us. Orbital debris is any man-made orbit in orbit about the Earth, which no longer serves a useful function. That is, life is over, the dead satellite, and non-functional spacecraft, abandoned launch vehicle stages, mission-related debris, and fragmentation debris. These are called space debris or space junk. Natural space debris or small pieces of cometry or asteroidal material called meteoroids. These are called meteors when they travel through the Earth's atmosphere. If you see what are the artificial space debris, it's a non-functional man-made object in space, as I earlier told. These come from following activities. The satellites that have been reached the end of their life, each satellite have their own life. It may vary from 1 month or 1 year to 15 years. It depends on the orbit and the design. Satellites and spacecraft that have failed, which are failed to put in the proper orbit, but still as a chunk it will be rotating in the space. Rocket stages that have launched satellites into space. So whatever these rockets are made of 3 stages or 4 stages. Mostly first stage separate within the atmosphere, so that will fall into the sea or somewhere. But other objects, other stages are separate in the space, which will go around the Earth, and it will remain there for many years. And nose cones, payload covers, routes, ports, and other launch hardware, which are all from launch vehicles. Solid propellant flag, which is from the first stage of rockets, is a small pieces of solid propellant, which will move around the Earth orbit at a very high speed, which is poses problem for other live satellites. These activities like accidental and deliberate, and some tools dropped by astronauts, distribution of fragments, or example, peeling of paint which is applied to the satellite for thermal and other productions, fragments from exploding batteries, fuel tanks, etc., mainly because of that end of the life satellite are left like that, which may batteries and other fuel tanks may explode and take many more fragments, more number of debris. And fragments from collisions, the accidental collision in the space, or deliberate collision made by man. Other sources of debris are collision, because the anti-satellite test in orbit, various countries are developing a space weapon to, which is called anti-satellite test, to make the weapon to destroy the satellites of other countries. They do some experiment, other thing. Many countries have done, including recently our India also has done. And when two satellites collide, they make thousands of pieces and creating lots of new debris. And as I told, several countries like USA, China, and India have used deliberately made some collision and the destruction of satellites which are in orbit. This creates thousands of new pieces in dangerous debris. So if we take account of satellites launched till today, more than 5,560 rockets have been launched from 1957, and they have launched 9,600 satellites so far in the Earth orbit. And number of satellites still in space is 5,500, out of which 2,300 are functioning. Remaining are a dead satellite, which is of no use, but as a chunk it is rotating the Earth orbit. What is the Kessler syndrome? This is an idea proposed by NASA scientist Donald Kessler in 1978. He told that a lot of space junk is in orbit. It could result in a chain reaction. If these debris itself collide with each other, and it multiply very rapidly, and totally it will cover the Earth around that, and it will make the Earth orbit become useless, and you cannot launch any more new satellites. This is what years theory has predicted. But this situation is extreme, but experts are worrying, but some critical things may happen. Totally Earth may not be, Earth orbit may not be blocked by debris, but some critical things may happen. That's what everybody felt. If you take debris, whatever present in orbit, Earth orbit, as of 2009, 18,000 debris of over 5 centimeters were tracked. As of July 2013, around 70 million debris, smaller in size, that is less than 1 centimeter, and about 670,000 debris between 1 to 10 centimeter, and approximately 29 larger pieces of debris are in orbit. So we are worried about the larger pieces, and small pieces it is very difficult to trace. As of July 2016, nearly 18,000 artificial objects are orbiting about Earth, including 1,419 operational satellites, which is around 2,200 at present. As of 2019, this is the latest information, 20,000 artificial objects in orbit above the Earth, including 2,214 operational satellites. Hussain, are you able to hear? Hello?
Yes, sir, we are able to hear. We had muted ourselves.
Okay, this graph shows the year-wise growth of space debris. You can see somewhere in 1957, the green line shows the rocket bodies. The rocket started launching in 57, and then red is the mission-related, that is spacecraft or launch vehicle and other thing. And blue line shows the spacecraft, whatever that is after a useful life, that is that satellites present is there, and fragmentation of debris, that is the small pieces as like exploded devices or some other thing. That is a pink, and the total object is a brown color. You can see year by year it is going on growing, which poses the problem for future space operation. And another thing, anti-satellite weapon, this I told deliberately, you destroy the satellite of other nation. For that they demonstrate by using their own satellite. So Soviets, they have used long back. They have done this type of experiment some 20 years back. They have conducted some 4 numbers of this type of destruction anti-satellite weapon, which created a lot of debris in space, and US also has tested some of the this type of anti-satellite weapon, and Chinese has tested recently in 2007, and that also has created a lot of debris in the Earth orbit. This shows that there is a Fenquins in 1C is their own satellite, which is put in the orbit, and with a KT-2 missile they are destroyed. Once missile hit the spacecraft, thousands of debris pieces are generating, and which will go around the Earth orbit. And if you take India, India is the latest country who has tested anti-satellite weapon, which is called Mission Shakti. This was tested in March 27, 2019. A ballistic missile defense interceptor Prithvi Delivery Vehicle Mark II, which is developed by Defense Research and Development Organization, which are mainly responsible for missiles of our country. It's struck and destroyed the Indian microsat or satellite, which is designed by again DRDO and launched by ISRO in the Sun synchronous orbit on January 24, 2019. In the low Earth orbit, 282 kilometers orbit, and relatively small in comparison to Indian communication. Normally, communication satellites are put in a higher elliptical orbit, which is called transfer orbit, and mainly because this is what put in a lower orbit, so that whatever debris generated because of the destruction is not going to pose much problem. When you are in a lower orbit, it within shorter time it enters the atmosphere and burn. So unlike Chinese ASAT, that anti-satellite weapon 2007, which occurred an altitude of 865, there is a higher altitude, and more than 3,000 objects have been generated, and this is still in space as a debris. But Indian DRDO has done demonstration of anti-satellite weapon. Around 400 fragments have been generated, of which 2,270 has been tracked, and most of the thing they told it will within 45 days it will enter the atmosphere and it will get burned. So not much problem is generated, even though NASA has made a lot of hue and cry that whatever India has done, they have generated a lot of debris which is going to pose problem for their International Space Station, which was not true. So this shows that is the left side, whatever is the satellite. This is a microsat Air, designed by and manufactured by DRDO, and then launched by ISRO from Sriharikota. And this is the launch. Their missile, which is targeted the satellite which was going around the sun synchronous orbit, and this was successfully demonstrated. This is the fourth country which has demonstrated the capability of anti-satellite weapon. And another thing is whatever is the people were thinking the space is very, 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 very large, and it's a big universe, and whatever debris in thousands of number or lakhs of number, the chances of collision is very, very, very rare. They told 1 in 10 lakh is the probability of collision. So they need not worry like that only. Even after Kessler syndrome prediction, people were thinking. But in 2009, there was an incident happened which is made a very dangerous message to all aerospace scientists in different countries. Yeah, there, Cosmos 2251 is a Russian satellite which was a dead satellite. That is, the life was over. So it is going in orbit around Earth without any control. It hit iridium concentration, that is US company, that iridium 33 number, that satellite which is used for communication, and it collided with that and it is gone into the pieces. The picture shows the artist view of that satellite, Russian satellites colliding with the iridium 33. So this chart shows some of the data of debris generated by different activities. So you can see from 1965 onwards. So rocket body, that is the bottom. I am reading from bottom. 473 pieces. That is number. Catalog number. That is NASA is tracking and giving some catalog number. So it is a 1965 because of the explosion of the rocket. The next Nimbus 4 rocket body because of the explosion in 1970, and 1986 there is a 492, that is the catalog number. These are all because of rocket bodies. And if you see PSLV-3 C3 rocket body, which is a catalog as a number 330, it is 2001. It is because of the explosion. And then if you see top was microsat Air, and it's a 400, it's a catalog debris, that is 400 numbers. So 2019. So intentional. This is purposely it has been done. Like that next one, iridium 33. So it is in 2009, that is what I told. It's a Russian satellite collided with the iridium 33. So this is gives some of the data of debris generated and accidentally or purposely. So this picture shows a comparison of debris, whatever is debris growth generated by space activities. You can see on the left side, this is 1968. So you can see very clearly less number of debris going around, and most of the things are around lower Earth orbit. And if you see 2018, almost it is a swarm of debris. It is full of a whole Earth is covered, Earth orbit is covered with debris, which is going to be a very critical and dangerous for future space activities. So this is computer generated debris. So you can see around the Earth, that is the low Earth orbit, lot of pieces are generated. And if you see further that other orbits, which is almost geostationary, is around 36,000 kilometers above the Earth, where communication and navigation satellites are put in the orbit. Number of debris is less because I will tell the reason why there is a less number. So another data, whatever I am going to tell is, suppose some satellite debris or satellite is that satellite is in different altitude, how much time it will take to enter the atmosphere and burn. So we are taking around 1,200 kilometers, not larger, higher kilometers, because it will take years and thousands of years to enter the atmosphere. If you take, if your any debris or satellite is in 200 kilometers, it will enter in within a day and it will get burnt. This is because of the gravitational pull of the Earth is very, very high. If it is in 300 kilometers, it takes 1 month. 100 years and 900 kilometers is 1,000 years, and 1,200 it will take a millennia. This is the thing, because it will go on go around the Earth because gravitational pull is very less compared to the near orbit. And now I will tell what are the problems of orbital-based debris. What problem it is going to generate. It can give range of problems in 4 main areas. If you see the collision, because it can collide with some other space, whatever orbital going on in orbit, it can damage the operational spacecraft, minor damage to total destruction. It depends on the size of the debris. And with the other debris, if you collide with another debris, it generates more debris. So two debris hit each other, maybe hundreds of thousands of debris, maybe further, which will aggravate the problem. Suppose you take application of space science, debris effects may be mistaken for other phenomena. When it comes the sight of telescope and other thing, it may give from wrong information for scientists. It may not be able to give the proper information about the space. Debris effects may mask other phenomena, so it will mask so that he may not be able to get the proper true information. And if we are talking about the area of astronomy, debris trails are increasingly prevalent astronomical images and images whatever taken astronomy about other planets, other things. This interfere and it may not be able to give true picture, and it's difficult to scientists to interpret and get a true actual information, and produce transient radio astronomical event due to reflection of ground and space transmitters. And over time, debris will increase the background sky glow. So a lot of debris is there. So it will produce a sky glow which may affect the astronomical instruments. Others are re-entry assault from large debris objects. If it is a very large, like for example, if you know now International Space Station is there, it is around 460 tons of weight is going around the Earth. If such a things are come down, it may fall any of the populated area, which will damage. And radiation hazard from some of the radioactive material used for interplanetary mission. If it fall on the populated area, it is going to give radiation and it may affect the health of the common people. So now what you have to do is we have to track the space debris so that we can plan our activities to safeguard whatever spacecraft or other space, whatever we are launching or whatever going to be in the orbit, operating in the orbit, future launching. You can save our asset from damage of space debris. Both USA and Russia have set up tracking networks to monitor the orbital space object population. And these are the pioneers. They are the pioneers. They have a network and they have coordination between them. And European Union, that is the ESA, what is the European Space Agencies, where many of the European countries have made some consortium, and they are also in aerospace launch space and rocket activities compared to NASA. And US Space Command and Russian space agencies, they join together, they make trace space debris and keep their object catalog. And they call it the US Space Surveillance Network, employs global sensor to feed its catalog. So they have a network for tracing these debris all over the globe, and they have cooperation between them. This is the US Space Surveillance Network. You can see they have all over the world, not in India, some other places. You can see they have their own stations, which is you can see the icon that the black color is dedicated sensors, and red color is the collateral sensors, and blue is contributing sensor. That is the collateral means they may be part of other activities also. So these are the surveillance network collect, trace their trace debris and give information to the control center. Worldwide network of 20 optical and radar sensor is there over their network. And space surveillance accomplishment. If you see, what is the purpose of this space surveillance? Predict when and where a decaying space object will re-enter the atmosphere. To track it and see and what at which orbit it is going, and predict when it is going to enter the Earth atmosphere, so that it can be prepared for any eventuality. Prevent the returning space object, which to radar looks like a missile, from triggering a false alarm and missile attack warning sensor of the US and other countries. So sometimes it may give wrong information so to radars, whatever they are using for the defense. They may think some missile is attacking. So you have to trace properly and see whether it is a missile or a debris, so that they can unnecessarily they cannot put their military in action. Chart present the position of space object and plot their anticipated orbital path. So this catalog they make to totally give the map of percentage where it presents and how which orbit it is going. And also additionally they can whenever new debris are generated, they can identify and correctly map. They can tell who has created the orbit that debris, and what is their intention. Is there any they are going to hit any other satellite or thing, and they can see who is the owner of that space or orbit, so that they can take some action. Inform NASA whether or not object may interfere with the International Space Station. And because NASA is mainly worried about the International Space Station, where always minimum 6 to 9 astronauts are staying there and doing the lot of experiments. They are worried about safety of their astronauts and also safety of their International Space Station. So NASA always immediately work out from this whatever catalog is derived from this surveillance network. And another is International Scientific Optical Network. It's called. This is a voluntary project of self-financing basis directed on monitoring the near-Earth space to obtain the data for scientific applied purpose. This is a voluntary project. They have a scientific network, maybe 14 countries. They have consortium, and they are working for it. And main purpose is get scientific and applied purposes. Cooperates with the 13 observation facilities of various affiliation with 97 telescopes in 16 countries. So this is their network. Main scientific topics is to trace space debris, asteroids, gamma ray bursts, afterglow. These are their apart from that astronomical. Apart from space debris, they do some other scientific information also they collect. This is the Keldy's Institute of Applied Mathematics, Russian Academy of Science supervise this network, and they coordinate with a database of objects and integration with Russian satellites at high orbit. So satellite also trace and they give information for this network. It is based on agreement between the institute and the participating other space agencies. And this shows the network of this ISON observatories. This is also almost throughout the global there. So blue color icon indicates the telescope with some 400 mm and above, and wide field average aperture telescope. And these are all different size of telescope they are presented in different locations, which collect the information about the debris from lower Earth orbit to higher orbit. And Japan is having their own system, what is called JAXA. JAXA is a Japan space organization. They have called what is called Space Situational Awareness System, and they have their own network. They have own radar and optical telescope. Radar is used for low Earth measuring the tracing the trace debris in low Earth orbit, and telescope are used for higher orbit like geostationary orbit, mainly to avoid collision and keep a catalog of orbital information, and also re-entry, estimate the re-entry is going to face any problem due to that in the Earth. That is the thing. So this is their network. They have telescope, optical telescope in center here, and another. This is the radar center, and they have this is the analysis. They conduct analysis in this center, Sasuba Space Center, which will produce a catalog and other information if it is critical to make any other operation. India's status on space debris tracking. So India also not far behind this tracking, but it is recently only started. So till now, no, this is before September 2019. ISRO was dependent on NORAD information, that is North America Aerospace Defense Command data, where they have put their catalog, whatever debris they have observed, they have made some catalog and they have put in the public domain for the use of other space missions, keeping track space debris, monitoring our activity and basic satellites they have put. But this data is not very accurate, and very accurate results are data are provided only for its members, and ISRO, that is India, is not a member of that network, NORA. So we are not able to get a very critical data. So far we are using only the data available in public domain. So ISRO felt that we also have to have accurate data about the debris in the low Earth orbit, because we are launching many satellites for our application in the low Earth orbit. So a network called Directorate under the Directorate of Space Situational Awareness and Management, which is already having in ISRO. There's one network called NETRA, that is a network for space objects tracking analysis at the cost of 400 crore. Started, planned and started in September 2019. That's what recently. So they have started the activities to trace the debris. for our application. So they established a multi-object tracking radar at Sriharikota. This is called the Satish Dhawan Space Center, where India is launching satellites by using our own launch vehicle, BSLV, GSLV, and all. Even Chandrayaan 2 recently has been launched from there only. There they established the radar to trace debris. And I have a plan under this project, this network. There will be one telescope will be set up at Ponmudi Hills near Trivandrum. So they are planned to put a 1 meter telescope where that mirror will be developed by one of the center of ISRO, which is in Bangalore. Our own indigenously that telescope will be developed in ISRO. So another thing is ISRO is have ISRO and PRL, Physical Research Laboratory. It's one of the organizations under DOS like ISRO. They have an observatory at Mount Abu to track space junk. So there we have 1 meter wide telescope, which is going to be established by ISRO's Laboratory for Electro-Optic System, which I told just now, which is called LEOS in Bangalore. It is they are going to establish there. Where already that space observatory is there under ISRO PRL banner. And another memorandum of understanding is recently signed between Aryabhatta Research Institute of Observational Sciences, which is in Nainital, which is already having a observatory, and there we are going to establish. They are already having a radar, and we are going to establish. ISRO going to establish optical telescope so that it can monitor near Earth object like there is debris, and it also can be used for other R&D studies in space weather astrophysics. So this is going to be funded by ISRO. This is already MOU signed. Maybe very shortly they establish the telescope. And debris mitigation. So instead of debris management, it is called mitigation. Mitigation means it is what it means is totally you cannot eradicate the problem. We have to minimize and you have to manage with the problem, because totally we cannot clean the debris from the Earth orbit, because even small, less than 1 centimeter is difficult to trace, and it may be difficult to catch also. But definitely compared to bigger debris, smaller debris also having equal potential of damaging any of the space article which is in working condition. So both are important, but it is difficult to smaller debris is difficult to trace. So following Kessler, that is 1978, as I told in the beginning of that, but till today, not much development or progress is there in mitigating the debris, that is reducing the problem of debris. So what they agreed is all countries and UN guidelines, so they have agreed following thing after Kessler's presentation of syndrome, whatever that in 1978. So every country is agreed to limit debris released during the normal operation, normal launching or satellite operation. They want to make as minimum as possible. So you cannot totally avoid generation of debris, but you have to keep minimum by some other technical or scientific means. And minimize the potential breakup during the operational phase. During operational phases, you should avoid any breakage, maybe because of non-function or collision between other things. That you have to minimize. You should be ready for it, and probability of accidental collision in orbit, so that you have to predict and trace the object, and anything is come in the way, you have to make a safer solution to avoid the collision. and intentional destruction and other harmful activities. So intentional destruction is an anti-satellite weapon. That is hitting, putting in your own satellite and try to hit by using another satellite by using laser or by missile or firing a rocket from the satellite itself. So such a kind of anti-satellite weapon that has to be reduced, which every country has to cooperate so that it can minimize, I think, minimize potential post-mission breakups resulting from storage energy. Post-mission means there is a life is over, and there is always once satellites left like that, there's a possibility that whatever batteries are there, it may get exploded after some time. Or tanks which is under some pressure and which is having some fuel, it may get exploded and create a lot of debris. So that has to be avoided by some means and some procedures. Limit the long-term presence of spacecraft and launch vehicle orbital stages in the low Earth orbit region after the end of their mission. What they call as the 25 years rule. That is one satellite operation is over, and this is mainly about the low Earth orbit, that you should enter within 25 years into the atmosphere and it should get burned. So they have to design their satellites in such a way within 25 years it is removed from the lower Earth orbit. That is the thing they are told. And limit the long-term interference of spacecraft and launch vehicle orbital stages with the geosynchronous region after the end of their mission. So this is geosynchronous orbit. I want to tell many of you may be knowing what is geosynchronous orbit. It is an orbit above 36,000 kilometers above the Earth. When you are putting a satellite into that orbit, 36,000 circular orbit around the equatorial plane, that is also having one revolution. That is, it makes one revolution around the Earth in a day. That means it is stationary with respect to the Earth. From the satellite, it will be stationary, always visible to the particular Earth station, and you can communicate to the satellite and you can operate. This is used for mainly for communication purpose. So once the life is over, you have to remove from the that is geosynchronous orbit, because the geosynchronous orbit is a unique orbit. So yeah, every country now want their own communication satellite or navigation satellite or weather satellite, which is required to be put in that particular orbit. So if it is crowded, you cannot put a new satellite. So you have to remove the end of the life, that is what is called a test satellite, from particular geostationary orbit, so that you can put the new satellite. In following slides, I will cover how that has been implemented. Now we will see, can satellite be protected from space debris? So there are two ways that satellites and spacecraft may be protected from orbital space debris, in fact. So one is a computer program reach possible collision between large space debris object and high value spacecraft. You can simulate with whatever data available and detect likelihood collision and maneuver the satellite, that is using small rocket, out of the collision, out of the debris, whatever orbit it is coming, you can move your satellite from that so that avoid the debris. And such maneuvers are carried out in the large spacecraft. It's a normal small spacecraft is difficult to implement, but the International Space Station and Space Shuttle, this type of provision is existing, because I told astronauts are there, astronaut lives are more important. So this maneuver can be done when International Space Station. So always they will do some calculation, and if the object is larger than 100 mm and there is a avoidance collision probability is more, then immediately they will do this operation. And debris shield can be designed to provide additional protection for a spacecraft. One obvious way is to simply increase the thickness of the wire. So you can do protection, that is, you can give a shield for the spacecraft or satellite, but it is definitely going to increase the mass of the spacecraft, and and which make the launch cost expensive, so it is very difficult to implement. But she'll take advantage of the fact that two thin walls separated by these are more resistant to debris. Instead of the increase the thickness of the spacecraft or launch vehicle, you can put two thin sheets separated by some distance, which is called a field shield. And this is done for some astronomers found out, and outer wall absorbs a lot of debris energy, so that the inner wall is not punctured. So whatever impact coming, outer wall will take. And this type of shield with modification has been installed in the International Space Station, and most of the small debris that are impacted on International Space Station has been protected by this type of shield. And this picture shows the International Space Station, and it is one of the marvelous of science and engineering of our mankind. This is the built for building. This is a total full configuration of the International Space Station. To build this full configuration, it took almost 12 years. 1998, the first module is launched, and afterwards, this is a consortium of different countries, and major is NASA, US, and this Russian space agencies, Roscosmos, and European space agencies. More than 12 countries are there. Japan is part of it, and Canada also part of it. They have their own lab and other thing to do experiments. You can see the big panels or solar panels produce required power for space station, for various labs, and chamber for astronauts. The size of the International Space Station is almost equal to a football ground. And that first satellite launched by Russian Sputnik 1 is the size of the football, and this is the size of the football ground. You can see what a massive structure is this. The first model launched by Russia. This is a fully assembled configuration. And now I will tell whatever how ISS, that is the International Space Station, is protected for space debris. The space station has orbital debris shields in place to protect space debris less than 1 centimeter in size. The space debris sensor also will monitor the small debris environment around the space station for 2 to 3 years. They have put a sensor so that they can collect data about small debris, whatever is there. Large debris pieces are tracked by ground control. I told that network they will track the debris whatever from, and if needed, the space station thrusters can be used to safely move the station away from the debris. So once that network track the space debris and they do analysis, and it shows there is a probability of the debris coming in the way of the space station. They will move the space station by firing their thrusters mounted on the space station. And data gathered during the space debris sensor investigation will help researchers make the entire orbital debris population for future application. That is mainly used for that one. This video shows the space debris sensor, what is mounted on the International Space Station, how it is working, what is the construction of that, how it is working, and data collected will be used for future mission. And it is mounted, you can see that some golden color, that This is called space debris sensor. It's called 3 shields, 2 layers. So last layer will give the information about the impact energy, whatever given. So this will be mounted there for 3 years, and it will help for future. Can anything be done to reduce the re-entry risk? So what other measure we can do to reduce the re-entry risk? If a satellite has maneuvering capability and still has remaining fuel at the end of its life, it can set up so that it re-enters over a large area of ocean. Suppose satellite its life is over, but still it have some remaining fuel. You can operate it so that it can enter the Earth atmosphere, so that it can, and it can be directed so that it can fall in the ocean area, so that it should not land, fall in the land area to avoid any harm to the population. But most of the satellites doesn't have that much of budget of fuel. NASA carries out a re-entry survivability analysis for all large spacecraft, and if this indicates that a significant fraction of object may survive re-entry process, they will attempt to control the re-entry of such object into a safe area. So they will do an analysis before launching it. If by design it have extra fuel and they can do this operation, they will do it. They will apply so that this can be, the dead satellite can be removed. If a large object is non-controllable, it may be possible to destroy the object through collision with the anti-satellite missile launched from the ground. Such a collision produces many thousands of pieces of space debris, each of which will burn up. Suppose some large junk is coming and it is estimated is going to hit the earth somewhere in the land, is going to hit some country or some city. You have to safeguard the population living there. Then you can destroy by using anti-satellite missile, but definitely it will produce thousands of debris. But life is important than debris management, so this can be done. However, as long as this is done at a sufficient low orbit, the additional space debris produced will all decay from orbit within a month or two. That's why I told earlier I showed the table where if you are putting in some 200 kilometer, it will come within a day, it will enter atmosphere. So such a collision has happened within less than 300 kilometer. Even sources of debris generated also is not worried, because within a month it will be get attracted by the Earth gravitational force and it will enter atmosphere. Once it enters atmosphere, due to high speed and atmospheric friction, everything will get burnt. Nothing will come to the Earth, and debris also removed from the Earth orbit. However, cost of such an operation is very expensive, and whether it is possible, you have to see. It depends on the cost estimate and other benefits. And now we will see what ISRO does to safeguard its launches. So whatever so far, whatever guidelines have been done, what ISRO is doing to reduce the debris, upper stage passivation. What I told, once upper stage, which put the satellite into the required orbit, there is a cryogenic engine or liquid engine is there, which carries extra fuel. So that has to be passivated. Passivation means that has been made from active to passive. So you have to make special design and valves to evacuate the remaining fuel into the thing, and so that it won't get and pressure you have to release from the pressurant tank, so that by accident it won't explode. So there will be only one number of debris. The explode, it will be hundreds of the debris. So you can make by passivation, can drastically reduce the number of things. And collision avoidance analysis is done before launching to avoid any debris hitting the launch vehicle or satellite. And space object re-entry estimation also is done, how it is going to be there. And space debris modeling is done with the software. Long-term evaluation of space debris and graveyard orbits for geosatellites. I told geostation orbit is very much important. So already more than 30 satellites have been launched for communication purpose, which is called INSAT series or GSAT series. Out of that, many of the satellites have been life is over, and those things are removed from the geostationary orbit and sent to graveyard orbit. That means it has been removed from 36,000 kilometer and taken another 200 kilometer above that 36,000 kilometer and left it there. So this geostationary orbit is vacant so that it is useful, and the next satellite you can launch. And what is ISRO? Another continuation of that, ISRO performs phase object proximity analysis, as I told earlier. And ISRO also do collision avoidance assessment with the available space debris data. And the following below figure shows the typical collision avoidance analysis for typical PSLV launch vehicle with the Oceansat 2 satellite. You can see there are some red mark in that. So these are the region where launch is avoided. So launch window is not available during that time. You should not launch. If you launch, there is a possibility some debris may come and collide with your launch vehicle or satellite. This is done for every launch. It is done. Now with their own network, they may do in a more precise way, because the total they will get a full data of space debris around Earth orbit. How ISS avoids space debris risk? I told Indian International Space Station, and smallest debris, as I told, reliably it cannot be detected, and avoid debris. Shielding is provided. If you see outside of the International Space Station, there will be a lot of damage mark because of this small debris. And next, United States Strategic Command monitors the low Earth orbit carefully, and so they have their own network. So they monitor, and is there any large orbit debris is coming and around near the space station orbit, and it is greater than 1 in 1 lakh chance of entering the around some area around the space station, they issue a yellow notice, and if any object has come, 1 in 10,000 chances entering that red alert is given. So, and this information is taken by the trajectory operation officer at Mission Control Center at Texas. They analyze, and if it is a threat to the space station, they will discuss with the Russian counterpart and whether debris avoidance maneuver is required or not. Once it is decided that the debris avoidance maneuver is there, I will give the information to the space station, and control center will do it, and they will avoid the collision. They will time of closest approach. They will 23.5 hours before that approach, the decision will be made, and operation will be done to safeguard the International Space Station. Apart from this space debris, whatever generated by the launched objects, rockets and satellites and other collision, and astronauts also have dropped many items in space, which are also rotating in the orbit, and which has also posed the problem, same as space debris. So astronauts, you may know, astronauts come out what is called space extravehicular activities. or spacewalk. They come out and do some operation on space station, recovering of some satellite or repairing space station or replacing some of the equipments. During that time, they have done a lot of by mistake, by accidentally they have dropped many of the items. So one is in 2006, the astronaut named P. Sellers, spatula he has dropped, and another Sunita Williams, you may be knowing, the Indian origin American astronaut who have a long record of staying in space and also spacewalk. She dropped a camera while doing an operation outside the space station. Another person dropped flyers in 2007, and crew lockback is dropped. Another man called Piper and Kimpro. 2017 is a nose three shield. When you are doing replacing it, he has done, and another person has done some wire tie. It has been dropped, and these are also going around the Earth orbit at the same speed as 8 kilometers per second, which is dangerous, and it also depends on the size of the thing. And this video shows the dropping of the tool back. So somebody is doing operation out. And this video shows the dropping of the tool back. So somebody is doing operation outside. You can see the tool drop. So always it is whenever they take out the instruments, that has been tethered with a astronaut by using some rope-like thing, and they have put it in intact with some bracket or button within their space suit. But in this case, that bracket has gave away, and you can see there's a tool back is dropped from, and is going into the space, and it will always go into the orbit. It is like another satellite or another object that will go around the Earth. Now this will come to the important part of message. So how to remove the space debris? Removing space junk, especially larger pieces before the fragment, is critical. So big piece before colliding with other thing and making more this is critical. Easiest to do this is slow the junk, causing its orbital altitude decrease. So it is going at a very high speed. You somehow impart some energy on it. You make slow. It is when it becomes slow, it is get attracted by the gravitational pull, and it is enter. Slowly it is decay. That is, if it is come around 400 kilometers, within a year it come to the Earth atmosphere, and it will vanishes. It is burn out. Several creative ways have been proposed for slowing fission down. So there are a number of methods for slowing this, including using laser gun or putting some plasma thruster to slow down. So many things they have done experimental. The most advanced technique include carpooning or casting a net, put a net and catch the space debris and put it in the atmosphere, and slowing it by attack, slowing by drag sail. There is increase in the drag until both captured and capture burn up. These are some of the methods we will see in the following. Ideally, the cleaner would sit some distance from the target and never touch. So who are going to catch that this debris, it will be kept away from the target so that it doesn't get closer, and it should not end up in collision of that. This accident should not always kept far away from the junk to safeguard the main object. For years, NASA, ESA, and other space agencies are studying different techniques. Some ideas proposed include nets, harpoon, spear, retrieve objects, and robotic arms. These are the things. Japanese scientists now developing a type of satellite that uses the magnets to catch and destroy debris. Just last year, UK successfully demonstrated the net putting around a dummy satellite, and they have demonstrated it successfully. So that there is some encouraging information is available for future application. So this is the artist view of Clear Space 1 as a Swiss spacecraft that will use a net to track the nanosatellite towards the re-entry. So it will put a net like that. You can see it is catching the small CubeSat nanosatellite. Whatever is life is over, and it will bring it back into the atmosphere. I will give the detail about the Clear Space 1. It is planned to launch in 2025. This technology demonstration is developed by Swiss Federal Institute of Technology. Mission is procured as a service contract with a startup-led commercial consortium. From the startup company, the collaboration for demonstrating it. And this shows the clear this. They plan to catch this Vespa payload adapter from earlier launch Vega launch vehicle. This satellite will go, their Clear Space 1 will go and follow it and catch it and return to the Earth using its own propulsion engine. That's what they want to demonstrate it. This video shows how Clear Space 1 is planned to operate. This is a Clear Space 1 satellite, which is planned to catch the already used rocket stage. So it is locating it and following it. It is catching another satellite, CubeSat, which is called a nanosatellite, which life is over, and got it, and it is keeping it intact so that it doesn't slip. Now it is using its own propulsion to enter into the atmosphere. Now both debris, whatever caught, and this main satellite also will get burned. Another is removed debris satellite, which is designed by Surrey Space Center from University of Surrey, which is called remove debris. This experiment they have some three type of experiment, four type of experiment they have planned. One is called this satellite was launched in 2018, 20th June from International Space Station. And it is having a net experiment which is conducted in 16 September 2018. It demonstrated its ability to use a net to capture a deployed simulated target. It successfully has done, and it is encouraging result. They have caught that satellite and put it in the Earth atmosphere. Another visual-based navigation experiment that is also demonstrated in October 2018, where they can have a navigation with a camera and other thing, which will be useful for future application. And another thing, the Carfoon experiment, which is planned in 2019 to catch another simulated target, and a boom will be extended. It will catch that. So another is track sail experiment. So they will open the track sail for the main mother spacecraft itself, which will increase the area, surface area, so that track increases, so that velocity decreases slowly. Because of that, it enters the atmosphere and get burnt. So let us see the picture. You can see this is a remote debris satellite. From there, they are releasing the two small CubeSat, what is called DS1 and DS2. This is there, and the net is open and it is catching it. Actually, one balloon will come up from the debris satellite 1, so that surface area is increased, so that it is easy to catch the using the net. Another is the harpoon, which is extending through the boom and catching it. And this is the track sail, which is the sail is opened after the end of the experiment. And this is the main satellite. And because the sail is opened, the track is getting increased multifold. And because of that, that satellite speed velocity is decreasing, and which slowly decay the orbit, and it will enter the atmosphere. And like I told, status of removed debris is already next experiment, then visual based navigation experiment, and then carbon experiment that has been all successfully done. And when their deployment of drag sail was targeted on 4th March, and they are given the command for deploying the drag sail, but it could not deployed. Some problem was there, and post investigation I found that partially the boom is not deployed. That's why it prevented that turtle sail from deploying. But because of this, they have got some feedback for their future design, and same design used in some of the solar sail used for go around the Mars. Some demonstration by NASA has been done. And Russia claiming that they have invented a self-destroying satellite. That means that once the life is over, the total satellite will get evaporated. That's sublimation. The material used for this kind of satellite are prone to sublimation. So once you give a command from the ground, so total satellite, whatever material used, will get sublimated. That means it will from solid state to become gaseous state. So without becoming, there won't be any solid debris, but it is much data is not available. They have patented. Maybe you have to wait for a lot of information from Russia. Russia, it has been difficult to get. Maybe this secret operation is going on. I don't know when they are going to demonstrate this technology. And Japanese also they are trying. Their plan is to 2022. They have some plan to launch aircraft to catch some debris is already there because of their some rocket pieces they are planning. You can see left side that spacecraft they are going to launch for debris removal. Right side is the debris already there in the orbit. And Russians, some sort of company has claim, they say they have some design, what is called a foam debris catcher. So it is autonomous satellite. This satellite will be launched in the Earth orbit, and it is on the way due to its magnetic attraction. It is going to catch whatever is you are seeing as spikes around the satellite. It catch a lot of small debris going around it. And what data they are planning to launch in 2021, that's what the information says. And what they say is that the satellite, whatever they are going to launch, it is going to weigh around 5 kg mass, and it can collect debris, and which may reach the total of 50 kg. And after that 50 kg, it will enter the Earth atmosphere, and slowly by decaying it by using their control available in the satellite. Once it enters the atmosphere, it gets burnt, and totally debris problem is solved. Another Australian researcher have proposed they are planning for hunter-killer satellite. That means whatever satellite they launch, it will hunt for this debris, and it will kill the debris satellite or debris pieces. So what they are for this, they are proposed to use electric propulsion called plasma propulsion jets, which is having two jets. It can be used in two ways. Bi-directional plasma ejection means that the satellite can fire a plasma blast at the space junk, which is move it away from its prey, but at the same time fire a jet in the opposite direction to keep it distance safe. So what it is this idea is not going to catch debris. It is going to fire the plasma thruster once he located the debris, so that once fire, it is going to retrograde the object velocity. That is, it is going to reduce the velocity of the debris, and once the debris is velocity is reduced, so decay will be faster. So once decay is faster, it will debris vanish from the Earth orbit within depends on the orbit within at least within a year. So here, what is this idea is, it is not going to one-time operation. So once one object, one prey it hunt and killed, it can go for next one. Then it depends on the capability of the plasma thruster. Till plasma thruster can be used, it has sufficient time, and then it can be used for many more operations. So this demonstration, what they claim, it is demonstrated in the laboratory simulation chamber, and they are working on prototypes that can be launched and tested in the orbit in a short time, and the time frame is not available. So now we have come to the end of this session. So now I am going to present some conclusion about whatever debris removal, what is that present situation. The institutional and commercial use of space is growing at an increasing rate. So space application is going on increasing. If you take maybe 2-3 decades, that nations involved in space operation were less number. You can count, and it is less than 6 or 7 or 8, not more than 10 numbers. And today, if you see, every country is involved in space activities. You can see even small countries even involved. And now you can see presently UAE, one of the Gulf countries, recently launched a satellite for Mars mission with the help of NASA. Isn't it? I have seen now what is called a name as a Hope, that one they have already launched, and recently there are some 3 missions are going on to reach mission Mars. One is UAE, another is China, another is NASA. All the 3 are going. Maybe all these 3 may reach in the same time, because it required some 6 to 7 months of time to reach Mars. So everybody is that. Everybody want to have their own communication satellite. Every country want to launch its own reverse sensing satellite or weather monitoring satellite. So number of things are there, and people want to have broadband internet and direct to home satellite for TV viewing. And many of the countries, companies or communication companies are coming with constellation of satellite. They want to put more than 20-40 satellites as a constellation to get a continuous service of communication in the low Earth orbit. So it's all increasing the problem of debris, so which is going to pose problem in the future. And comprehensive national and international mitigation measures exist, but compliance is insufficient. So even though after Kessler syndrome, people taken it seriously, and with the UN Council, they have made some committee, and they have all face firing nations or signatories of those resolution. These mitigations are not effectively followed, that's what it is not going to fully solve the problem. Then you have to avoid international generation of debris. That is mainly anti-satellite weapon. Now, after following Russia, US, and China, India has done, and we don't know which other country is planned. So that type of thing has been banned. It should not be done in future, which will produce thousands of debris and pose a very critical problem for existing satellites in orbit. And accidental explosion has to be reduced by proper monitoring and proper action taken by tracking the space debris already is there. So that has to be avoided, like Russian satellite colliding with the EDM satellite. Such a type of should not happen in future. And a 25-year deorbit rule for mission in low orbit should be followed strictly. So whatever is already agreed by it, but a major of the missions it is rather it is not following. So that should be followed so that it should take that into design itself. It should take into account for this implementation of this guideline, so that within 25 years, that whatever spend mission like a dead satellite or end of life satellite, they should enter the atmosphere, clearing the Earth orbit. And geosynthesis satellite and whatever I told, because it is a unique satellite, orbit to gray or Earth. So that has been almost there is no the person is claiming that they invented some material which can sublimate once some command is given from the Earth, it can sublimate and it may go into the gaseous form. This type of things going to be invented. Maybe it may be possible technically. There are a lot of marvelous things happening in engineering and science. And design of future spacecraft and launch vehicles for autonomous deorbiting, lifetime reduction, and deorbiting is for new missions, reducing the collision hazard. So in future, whatever satellite or launch vehicle whatever stages are separating, there should be autonomous deorbiting. They should put some deorbiting mechanism, so automatically it should deorbit and enter the lower orbit, so that it will slowly it will decay within a year or time. So these are the possible solution to avoid space debris. So like I told, it is totally we cannot eradicate. It is a mitigation to live with it, to minimize the space debris generation and other things, so that we can avoid in future any loss of active satellite or rockets. So this I end my presentation.
Thank you very much, sir. I hope this session had given a good understanding of space challenges, and the entrepreneurs have also got to know the scope of innovation in creating sustainable space exploration. And I really loved the detailed description of minute stuffs in this beautiful way. I mean, like the number of space debris and the size of space debris, what are its density over various altitudes. Everything was fabulous and very simply explained in those slides, and I really loved those slides because there was no any confusion in understanding those slides. And now I request our students to must fill the feedback form. We also want to know how you felt after this event and after this session. And if anyone is facing any kind of technical issue, they can contact us on our support email, that is support@team2020.rf.gd. As promised, I want to inform you all listeners that IIT Bombay is going to conduct a cluster of digital courses on various technical and non-technical topics. Those courses are really very helpful for you and to improve your skills. We will be releasing the detailed notification soon, and a procedure to utilize that online platform also will be updated to our YouTube channel. Subscribe to our channel for not missing that update. Now, on the behalf of Team 2020, I want to thank Professor Ramaiah Arunachalam for accepting our invitation, and also I want to extend my heartiest thanks to Professor Ilangovan for helping us organize this event. And we will be back with a lot more stuffs and webinars and short courses with great stuffs. Till then, stay safe, stay connected, and keep learning. Thank you very much, Team 2020.
Team 2020.